So the first part of this section, we're talking about two postulates, the parallel, what's it called, parallel line and perpendicular line postulate, something like that, which basically just says from a line and a point, if I've got a point and a line, and I'm looking at the relationship between that point and that line, through any point, I can only draw one line that's parallel to the other line I've drawn. So even if I have let me just go up, a point and a line, through this point, there's only one line that I could draw that's parallel to this one. I could draw an infinite number of lines, but only one of those is going to be parallel. Okay? The same is true with perpendicular. I could draw lots of lines that intersect L, line L, but only one of those lines is going to be exactly perpendicular. Okay? So what I want you to do is, on this paper I'm handing out, just use the back for scratch. Using your ruler, draw a straight line with the pencil. Just a line like they've drawn up there. And then draw some point above the line. Doesn't matter what the distance is. And I'm going to play this video. And you are going to practice using your compass, following the instructions in the video, to construct a perpendicular line. Let's see. So they've drawn their line and they have a point. I'm going to start it. Okay? Okay. So what they did, open your compass up. Doesn't matter to what. Just open it a little distance. From your point, using this exact same distance, draw one little arc on the line here, and then move it over and draw the other arc on the other line, keeping your compass exactly the same.
Okay, well, that didn't work. So I need to open up a little more.
Yeah, I do.
If you did it right, the arcs should be the same distance from the point.
To keep it accurate, just draw the entire half circle.
Yeah, you could do that too.
My line didn't go all the way, so I'm going to finish.
Okay. Doing a little art and geometry today.
Yeah, I'm not good at art.
Neither am I.
Mine are even.
Although my sister, on the other hand.
Let me know when everybody's gotten to this point where you've drawn your two little arcs on your line, or in a complete semicircle is fine too, beneath it. You guys done over there? Reese, are you done? Okay, here we go. Now you're going to take the point. You're going to take the point, and you're going to align it with the intersection of that arc and the line. So you're going to line it right here. And you're going to come out, you may have to widen your compass a little bit. You want to come out so that you're connecting somewhere below the line. And use that same measurement from the other intersection below.
Whoa! It's really hard to use this compass. It's heavy.
Here.
It's really hard. You can see it's the same distance on either side.
And then leave it like in the middle down there.
Boom. Perpendicular line.
Yeah, and then do it on this side too. Go make an X.
Oh.
Everybody get that far?
Yeah.
Now if you just connect the intersection of these arcs with the point you started with your ruler, you have now drawn a line perpendicular to the original line. And if you measure it, if I gave you a protractor, you'd measure it and you could see that it's 90 degrees.
So we can very easily assume that that
Yes.
is a right angle.
There you go.
Wow.
Wow.
I know I did that.
Pretty cool.
Is mine a 90 degree?
So you've just proven there's only one way to draw this line that is exactly perpendicular from the point to the line you're drawing it to. Lots of other lines we can draw, but only one will be exactly perpendicular from that point, and you've just drawn it.
Nope.
Okay.
I was literally thinking about that in my head. I was doing it on the trying to do all of this.
It doesn't work. You cannot fit the marker in the compass.
Well, that makes small enough.
Let's see what this one is.
Well, Christian's right.
We just did that one, didn't we? Oh. Perpendicular to a point on the line. So now draw it like this. Draw a line and put a point on your line.
Oh, I ran out of room.
I'll get you another piece of paper.
Can I have one too?
Uh-huh.
I got a 62.5 out of 63 on that.
There might be two there.
You shoot. Oh, there is. Whatever. Probably gonna
Do you need another one? Either of
She'll
you?
actually
Yeah.
give you every single answer if you.
Do you need another one, Ethan?
I did.
Okay, so draw it like that. Draw a line and put a point somewhere on it. Everybody there?
Anywhere on it?
Yep, anywhere on it. Now we're going to work on drawing a line perpendicular to that line that goes through that point. So open it up. Draw two arcs from that point.
This is gonna be small.
Everyone make it that far?
Just a second. I'm having real trouble with this compass.
Are you good?
Yep.
You good, Ethan?
I'm just not good with compy, I guess.
Okay, so now you're going to put the point at the arc. Open your compass so your pencil's a little further than the point is away from the arc. Just open your compass just a little bit. So the distance from your compass to your pencil is wider than that arc to the point.
Oh, maybe that's what I went wrong last time.
And then put your point on the intersection of the arc and the line, and the intersection of the arc and the line on the other side, and draw two arcs above the line.
You could kill someone with this thing.
Lost?
Yeah. I got the X.
Oh, well, you're done then.
Oh, okay. I thought you said like maybe bigger arcs.
No. Everybody get this far? Yeah. Then just connect
You're a little too serious.
the point with the intersection of those two arcs, and you've just drawn a line perpendicular to the other through the point that you drew on your line.
Not said you need a butt out.
I thought you said, what am I going to do about it?
What are you gonna do about it?
Now you know that is 90 degrees.
Look at that.
Pretty cool.
I feel like a pirate.
What?
You never see a pirate using a compass and a map to figure out where they are?
I don't see very many pirates.
Okay, the next section. I'm sorry we're done with constructions now. I know. Oh, we'll come back to them in different sections, but
Draw a 6-inch circle.
the next section, or the next page of this section, we're learning about parallel lines and something called a transversal. And a transversal is just a line that's drawn between two parallel lines that intersects both lines at an angle, like the one in blue here. They don't always have to be at an angle like this. They could be straight through at a 90 degree. It's just a line that intersects both parallel lines. It's called a transversal. Okay? And when it intersects, does everybody see that it creates 8 angles?
Yeah.
Here they are. It creates 4 around the top line and 4 around the bottom line. And this section we learn all of the relationships between all 8 of these angles. Everybody see that angle 2 and 4 are supplementary up here? And 1 and 2, and 1 and 3, and 3 and 4, those are all supplementary angles, right? Same, I could just do 5 and 6 are supplementary, 6 and 8, 7 and 8, 7 and 5. Okay. What we learn with these angles are the angles that are opposite each other, like 2 and 3. What kind of angles are those? Nope. What's Angles 2 and 3, what's the special name for those two angles?
Congruent. Nope.
They are congruent, but what are they called?
Vertical angles.
Vertical angles,
Oh, that was in, okay. That was
right? Angle 1 and 4, vertical. 5 and 8, vertical. 6 and 7, vertical. Okay? When they're parallel, and only when they're parallel, we know some relationships between these. Angle 2 and angle 6. Do you see how both of those angles are above the line they're on? They're on the same side. They're called corresponding because they correspond to the same position on both lines. Corresponding angles. Angles 2 and 6. Give me another set of corresponding angles.
1 and 5.
1 and 5, another
4 and
set. 4 and 8, another
3 and
set.
7.
Good. Everybody see those? Corresponding. Okay. How about if I tell you, look at angle 3 and angle 6. Do you see how they're on opposite sides of the transversal, but they're inside both of the lines? They're called alternate interior angles. They're on alternate sides of the transversal, and they're inside or interior to the two lines. Those are alternate interior. So if 3 and 6 are alternate interior, what's another set that's alternate interior?
2 and 5.
4 and
4 and 5. They have to be inside the two lines. Do you see L and M? Do you see inside L and M there's 4 angles?
Yeah.
3, 5, 6, 4. Okay, the two angles inside L and M that are opposite opposite sides of the transversal are called alternate interior angles.
Okay.
3 and 6 and 4 and 5. Those are the only two sets of alternate interior angles.
Can't do it with the top one.
No, we'll get to those. They're not interior. Okay? 2 and 7, do you see how 2 and 7 are outside?
alternate exterior.
They're alternate exterior. So give me another set of alternate exterior angles. 1 and 8. Okay? There's also something called the same side interior. So what do you think if I told you same side interior? 3 and 5. And then the other set is 6 and 4. Okay? So you need to know all 4 of those names. You need to be able to, if I ask you, give me a pair of corresponding angles, you need to know what corresponding means. Give me a pair of alternate interior, you need to know alternate interior. What's that?
Corresponding is 2 and 6.
2 and 6, 1 and 5, 3 and 7, 4 and 8.
So there's like an angle between them.
Yeah, they're on the same side of the transversal at the exact same location regarding or compared to both lines. They correspond to the same angle.
So like 4 and 8 would be 1, 2.
Yes.
Okay.
4, 8, 2, 6, 1, 5, 3, 7.
Okay, when you see something like this, where we have two lines that aren't parallel and a transversal, we still can create those kinds of angles, but there's no relationship between them. When they are parallel, and I don't know if we talk about that in this section or not, but I'm going to just talk about it now because it goes along with what we're saying. So this is the relationship. Corresponding angles, alternate interior angles, alternate exterior angles in a parallel system, so if it's parallel lines with the transversal, are all equal to each other. I'll say that again. Corresponding, alternate interior, alternate exterior are all equal to each other. Yes. So if I knew angle 2 was 30 degrees, what other angle do I know is 36 by which kind of angle is it?
C1, what is that?
Yep. Corresponding, okay?
But also
So
3 would be 30 degrees, right?
give me, using alternate exterior, what angle is equal to angle 2?
7.
Good. Corresponding to angle 1?
5.
Yes. Alternate interior to angle 3?
6.
6. You following? Alternate interior, alternate exterior, and corresponding angles are all equal in a parallel line system like this one. Okay? Now, there's something else that we know in the parallel system. Same side interior. Tell me a pair of same side interior again.
6 and
4 and 6 are supplementary.
Come on.
Are supplementary, meaning they add up to 180.
Complementary is
4 and 6 and 3 and 5 are supplementary. They add up to 180. Everything else is equal. Alternate interior, alternate exterior, corresponding, equal. Same side, interior, add up to 180.
This is like the first time I've understood, for the most part, what's going on. It's pretty nice. Like, from the get-go, I understand it.
Okay? So that is it on this section. Big Ideas is open.
Oh.
CK12 is open.
Let's get to this bread.
Make sure you check your grades on Infinite Campus to know if you've got some missing grades.
Sweaty. Like a slippery sound.